So today we're going to be talking about Boyle's law. So Boyle's law relates to the volume of any definite quantity of gas that is held at a constant temperature. It shows that the volume is varied inversely as the pressure of the gas. So that in simpler terms is shown right here, where my volume is proportional to, that symbol means proportional to, 1 over the pressure. And if we wanted to get something like an exact relationship, we would need some kind of constant. Constant is shown here, our K1 over the pressure. So this constant gives us an exact relationship between our volume and our pressure. So how are we going to get this constant to give us a nice exact relationship? Well, if you look at our graph here, you can see it's a graph of pressure against volume, and as our pressure decreases, our volume increases. But this, you can see we have 4 different lines here. Each of these lines represents a different temperature. So the gradient at which pressure and volume vary is based upon the temperatures shown here. And each of these lines here will give us a different K value. And so in order to get this relationship, at least experimentally, we need to use what is called a isotherm, where we hold a constant temperature throughout the experiment to get a relationship of our volume and pressure. So if we take this a little bit further and we multiply over P, we can get pressure times volume is equal to our constant. Now, because as you can see with our graph on the right side here, that the relationship continues as there is a change. In other words, it gives us a slope, right? We can relate our constant K1 here to a beginning state and an ending state. And because the line is the same all the way through, they both relate to each other. So we can get P1V1 is equal to P2V2. And with this equation, we can rearrange it to get it in terms of pressure and volume. So our final equation here, P1, P2 equals V2 over V1. And this is useful in a case where we might want to find a final volume or final pressure of a gas. So that will be found on this problem right here as a quick example. Given a gas with a starting volume of 2 liters and a pressure of 35 atmospheres, what is the final volume of the gas if the pressure is reduced to 25 atmospheres? So we know from before we have P1 over P2 is equal to V2 over V1. And so we know that our starting pressure, P1, is equal to 35 atmospheres. Our ending pressure is equal to 25 atmospheres. And our starting volume is equal to 2 liters. And of course we want to find our ending volume. Okay? So when we set this up with the equation used here, we are going to get 35 atmospheres divided by 25 is equal to our V2 over 2 liters. Okay, and then when we go multiply this out, we are going to get our atmospheres to cancel. Our 35 divided by 25 is equal to 1.4. We're going to multiply our 2 liters over. So we're going to get our 1.4, which has no units because it or atmospheres canceled, right? Times 2 liters, and that will be equal to our V2. And so 1.4 times 2 is equal to 2.8 liters. So one more time, what this question is saying, if we have a gas with a starting volume of 2 liters and its pressure is 35 atmospheres, if we want to reduce the pressure to 25 atmospheres, we will have to expand our container to 2.8 liters. But there is one very important caveat that must be included here, and that is, change my color here, that this must be at constant temperature.